In this video, we're going to go over the field exercise principles in the Sustainable Trail Layout 1 Field Lab. In particular, I'm going to explain in a more visible format what's meant by the idea of trail slope alignment angle. So, in our trail exercise, we were to mark an X, marks the spot for our starting point, so a trailhead. And then again, at a distant location, in our case for the field lab, just about 100 meters away, a destination, which was also the highest point on our little map. Or, in this case, a peak in your mind's eye, or a prominence, which is a high area that's not necessarily a peak. It's just higher than all the other spots around it. And then in our field lab, the assignment was to, 2 different times, plot some kind of a walking trail that sort of meanders through Thompson Woods to get from our starting point to our finishing point. I'll do those as 2 different weighted lines. The idea of this part of the exercise being that there are lots of different ways, literally infinite, to get from point A, our starting point, to point B, our destination. And everything in terms of the sustainability of this trail, the safety of this trail, the enjoyment and the effectiveness of this trail in helping visitors to your wilderness area understand what's going on, have a good time, enjoy enough but not too much challenge, and so forth, all depends on the line that you select as the center line of the trail. Now, ultimately, we don't have to worry too much about making a mathematically optimal trail in the sense of if we connect this trail from any starting point. Oh, let's undo that. We can connect this trail from any starting point up to this destination, but if we do that in a straight line, because our destination is very commonly some kind of a high point, like walking towards a mountain peak or vista point, something like that, that is by definition always going to be going straight up slope. So if our initial point is 100 meters in elevation and our destination point is 1,000 meters in elevation, this is a very, very steep straight line hike. And unfortunately, of course, water is going to get entrained on that trail because we're clearing it. And anytime you have an overland flow event, and especially after the trail is compacted and there's less infiltration ability for the water to soak through the soil following that precipitation event to recharge the aquifer, it's going to flow over land and get trapped in that trail. It's going to be a muddy mess, highly erosive, less safe, far less pleasant for visitors. People hate walking with wet feet, and so forth. So for pretty much every reason, we really want to avoid having any sort of a straight line or direct ascent trail from a starting point to even a nearby prominence before we get to the destination. Instead, what we want to do is slab around or contour around or stay mostly iso-elevational and move up and down the slope even when in a net effect we are climbing the slope. So the way we do that is we put wiggles or meanders or wanders or switchbacks in a trail. When a trail is gently turning a corner, that's called a climbing turn. And that's pretty sustainable. This is a great solution at large turn radius for horses, at tighter turn radiuses and banked turns for mountain bikes, and tightest radii of all for hikers who can explore what is interesting around this next corner. Now, the directions for our particular lab were to get 2 lines plotted in, and then for each of these 2 trail center lines, just arbitrarily drop some points along the trail, a half dozen to a dozen. The particular number doesn't matter so much for the purpose of this exercise. In a production environment, like at a busy national park with hundreds or many hundreds or even a few thousand miles of trail, then we would basically be deploying our trail crews periodically to take these measurements that we're about to simulate here every couple of years and monitor the condition of the trail for stuff like erosion, and use these points and the measurements that we take along these points to figure out, did we inherit a sustainable trail system or a not so sustainable trail system? And it's, as it turns out, from the field research and the science involved, fairly easy for us to do this. So let's take one point along our first or thin line trail. We want to calculate something called the trail slope alignment angle. And that's nothing more than an arrow pointing directly upslope in our very simple map. Our destination for this trail is the highest point on the map, and so we can assume that everything sort of drops in elevation uniformly away from that. This would be like a conical peak, or a cinder cone volcano, for example, has a very uniform conical shape to it. That's what we have in our little example here. In Thompson Woods, our exercise also had a uniformly conic area. We went kind of straight uphill eventually from our starting point at a fieldstone to a destination point, the highest point in the area, further into the forest. So we draw one arrow that is the pointing up, straight uphill. That's called the landform angle. Or this is the back azimuth, or the 180 degree opposite of the hill slope's aspect or facing. Conceptually, they're really the same thing, even though the numbers vary by 180 degrees from each other. The second arrow that we draw is directly along the trail just at that point. Now, notice that even within the length of that arrow, the trail curves away from that direction just a little bit. We don't care about that. We just care about what direction the trail is facing, forward and back as you travel along the trail at that one point. This is the trail or tread, sometimes we use those terms interchangeably for this exercise at least. That is the tread azimuth. And what we want to know is comparing either the forward direction on the trail against that landform angle. What angle does that form? Or if that angle is greater than 90 degrees, we take the other pair. So we would take the direction the trail is running at that point in the opposite direction and compare that against that landform angle. And in that case, this would be slightly less than 90 degrees. For reasons of how water likes to flow, a trail slope alignment angle that is less than or equal to 90 degrees, because it cannot be greater than 90 degrees. That's our right angle versus the direction that the hill is running up or down. we want the trail slope alignment angle to be somewhere between 75 degrees and 90 degrees. So, at 90 degrees, trail slope alignment angle, what that looks like is this. We have a high point and contour lines around it. And a trail that is moving along, and at any given contour line, the trail is exactly perpendicular to the direction that the hill is gaining or losing altitude in. Okay? This is a very sustainable trail because water flows across this. If a raindrop hits right here, it's going to hit the trail in that spot, and instead of flowing along the trail, it will flow across it and continue down the slope and eventually recharge the aquifer underneath or the nearest surface body of water straight down slope. By contrast, let's say a 15-degree trail slope alignment angle looks like this. In the same situation, where we have a peak and a couple of contour lines around it showing the elevation dropping as you move off the peak, and a trail that is moving in a very sort of direct approach manner. Where that trail crosses the contour line, we would draw that arrow for the direction it's going in, right at that spot. And then we would also draw a second arrow pointing directly upslope. That's only about a 15-degree angle. And you can see just visually, without having to do any real math, that water that hits upslope from that spot on the trail is very easily going to get trapped and flow instead of across the trail and off it safely and ecologically sustainably. It's going to flow right down that trail. It's going to get entrained and trapped, and now we've got a new stream bed that we created. This changes the surface hydrography. It dries out meadows. It kills plants. It changes composition and allows non-native invasive species to grab a foothold in a more dry and moisture-depleted regime. It grasslandifies instead of afforests. This has all kinds of bad effects associated with how we decided to run the trail, whether it was a sustainable trail slope alignment angle greater than 75 or less than or equal to 90 degrees, or really pretty bad, like 15 degrees. Now, as it turns out, even something that would feel pretty shallow, like a 45-degree angle, crossing a contour line, not so good. Not so good. That's still enough to entrain a bunch of water and so forth. So, back to our exercise. For each one of these just randomly or arbitrarily assigned spots along each of these trails, draw an arrow following precisely in the direction that the trail is going at that spot, and then draw an arrow directly towards the summit, and just estimate for yourself, is this greater or less than 75 degrees? If it's greater than 75 degrees, tally that up as a sustainable chunk of trail or segment of trail. This point really represents a short section of trail all around it. So greater than 75 degrees, we've got 1. And for this next point, moving towards the peak, the trail's running in this direction at that point, and the peak is not too far off of that in direction. This is less than 75 degrees. So we would do a tally on that one for less than 75 degrees. There. And do the same for each of the points. Until you've got them all. have some tally of sustainable versus less sustainable sections of trail. Now, remember, this is a training exercise, and we're doing it in Thompson Woods, so there's no real wrong answer here. We ideally, eventually, and in a real production environment where people are actually going to use this trail, and we're actually going to cut the trail in, we really need as much of this trail to be aligned more than 75 degrees off of the direction of the slope. We really need that. Otherwise, we're going to be repairing that section of trail over and over and over. And if we do this, if we just cut in a trail that, broadly speaking, takes its time getting to a peak because it is respecting the basic need for water to flow downhill by making sure that most all of the points along the trail are greater than 75 degrees off of the direction towards the summit, well then we don't have to put in a bunch of expensive water control features. We don't have to put in a bunch of heavier rocks to function as French drains or stepping stones or what have you. Everything just works better. So it's a little bit more work to cut more kilometers or miles of trail because it's winding instead of direct approaching. But in the long run, this trail will outlive you. It can live centuries sustainably with an absolute minimum of maintenance. Very cool stuff.